Hello and welcome back to my Astronomy Nights. I'm Derek, and in this video we'll be looking at Messier 76, the Little Dumbbell Nebula. This is a small but really interesting target in the constellation of Perseus. It's a planetary nebula, one of 4 in Charles Messier's catalogue, and even though it's in the boundaries of Perseus, it's kind of halfway between the gamma stars of Andromeda and Cassiopeia. This is a circumpolar target, so if you're in a northern latitude like myself, it's available all year round, but it's best to observe between maybe August and February. In this video, I'll be looking at what it is, where it is, who observed it first, and how it might look through your imaging setup or your eyepiece. So let's begin by pinpointing its exact location on the night sky. So to find Messier 76, the best thing to do is to look south or just southwest and find that large square of Pegasus this time of year. And we're looking for the gamma star of Andromeda to begin with. This is the third star out from Alpheratz as you follow them, the alpha, beta, gamma stars in Andromeda. And then you want to look across to that W of Cassiopeia. We're looking for the center star Navi or Gamma Cassiopeia. And the halfway point between both of those is where we're looking to pinpoint Messier 76. It's about 8 degrees below the double cluster in Perseus, so if you're following around with your naked eye, you should be able to see that as another point of reference. We're looking for the bright magnitude 4 star Phi Persei, which is just inside the border of Perseus, and then we want to look just a little bit to the northwest of that for a nice yellow-orange magnitude 7 star, which sits right beside Messier 76. It's about 12 arc minutes or so. So if you can get that orange star into your finder eyepiece, you'll be able to search for the nebula just nearby. It'll appear as a small grey elongated rectangle. So Messier 76 is also known as the Cork Nebula or the Butterfly Nebula, but it's probably best known as the Little Dumbbell Nebula, especially when it comes to astrophotography. This is a small object at magnitude 10.1 and it measures 1.7 by about 2.5 arc minutes. It's in the constellation of Perseus and it was first discovered by Pierre Marchand in September of 1780, and then Charles Messier followed up and observed this in October the same year, and it became the 76th member of the Messier Catalogue. He described it as a starless, small and nebulous cloud. Later on, William Herschel observed this, but he seemed to think it was 2 separate nebulae side by side, so it ended up getting designations of 2 NGC objects of 650 and 651 for either of those lobes. He saw it being separated by a little dark lane in the middle of it. But it wasn't really until Isaac Roberts, a Welsh astrophotographer, an early astrophotographer from the end of the 1800s, he was getting photographic plates and he thought it to be a side-on view of a nebula similar to, say, the Ring Nebula. So he thought it was more of that side-on view or something like that. He got a wonderful amount of astrophotography photos taken back in between 1880s and the 1890s, and he's a wonderful catalogue. I'll leave a link in the description below because it's really fascinating to look at those early images that he was capturing. He was using a 20-inch telescope and he was manually guiding it with a 7-inch telescope to the side of it. It's some wonderful stuff. It used to take 3 or 4 hours to capture some of these images. So magnitude 10.1 with that size of 1.5 by 2.5 arc minutes. It's quite small in the sky, but in real terms it has a diameter of 3 million light years, so the same as Messier 27, the Dumbbell Nebula in Vulpecula, but it's just at a much further distance of 4,000 light years. It's expanding out at 45 kilometers per second, that bubble of gas, and the whole object on the north and south lobe is tilted towards us at 75 degrees. So you can just picture that kind of hourglass shape tilted towards us on the northeastern edge. So the term planetary nebula was coined by William Herschel in the 1780s when he was observing a nebula that reminded him of the shape and colour of the planet Uranus. But Charles Messier's list had these objects included before he had come up with the term, and he had 4 objects which included M27, the Dumbbell Nebula, M57, the Ring Nebula, we have the Owl Nebula of M97, and then the Little Dumbbell Nebula M76. These are all similar planetary nebula, but we're looking at them as slightly different orientations. Now, a planetary nebula is that late stage in, say, a low mass star where it casts off outer gas as it's burning through its hydrogen and helium and working itself down to a carbon oxygen rich core. So you get this gas that's getting ionized by that small star in the middle, and it becomes visible to us, but it's for a short period of time compared to the overall life cycle of a star. They're only visible for between like 10 and 50,000 years. and you're looking at that bubble of gas that's cast off with the star still in the middle, just sending out that UV radiation to ionize that gas and make it visible to us. But the way it stretches out, sometimes there's gas around the equatorial regions of the star, and it creates that kind of hourglass shape where the gas moves off in the path of least resistance. So you're looking at it from these different orientations. So not all planetary nebulae have that hourglass shape, which can be caused by gas around the equatorial regions of a star, or it can be caused by having a companion star as well in the system. But I'll just use the hourglass as a reference or an exaggerated reference for when you're trying to picture what you're observing in the night sky. With M27 and M76, you're kind of looking at it just slightly tilted, so you get that shape with the two lobes working on the north and south side with the gas bubble around it, and that's the path of least resistance for the gas to push out away from it and then get ionized. But when you're looking at the Ring Nebula, we're looking straight down the barrel of the north and south lobe. And then with the Owl Nebula M97, it's slightly off-centered, so it creates that shape with the two eyes in it, like an owl, but it's actually the north and south lobe we're just seeing through that transparent gas lane. But it's really interesting to picture these orientations when you're observing them, and some of them are spreading off. I think it's Abel 39 in the constellation of Hercules, and it has that lovely spherical shape where you're looking at the bubble of gas, so it's one I'm looking forward to trying to image when Hercules comes back up around and is well placed. So to capture my data for Messier 76, I used my QHY163 mono camera. I had it on my 8-inch Skywatcher reflector, and that has a focal length of 1000mm, but even still, it was still a small image to be capturing at that focal length. It came out quite well. I got some nice colors in it. I ran my RGB filters on it for 2.5 hours or 3 hours each over 2 nights, but my usable data was much less due to low cloud coverage throughout the nights. So I ended up with just about 1.5 hours to 2 hours per channel. I still was able to get some good detail out of it. I made a luminance out of the 3 colors just to add some of that detail to the outer tendrils, but I think if I ran a full monochrome luminance on it for maybe a night or 2, I should be able to tease out some of that outer detail a bit better. But I'll probably wait until the window opens up again after summer to get some good details on it. So for my observing sessions on this one, I was using my 12-inch Dobsonian. It was the best focal length I had to use at 1500mm, and it's an f5 telescope, so it gets kind of a nice bright image on those smaller targets. When you're observing this one, it's 2.5 by 1.5 arc minute or so overall size, but you're really only observing that kind of central torus, which is only about 1/2 of an arc minute by 1.5 arc minutes across. So you'll kind of be bringing out more of a little grey rectangle than that overall kind of dumbbell observation. But if you spend enough time on it, you can tease out a little bit of those kind of arcs that come out off the end, kind of reminiscent of that apple core shape that you get from the Dumbbell Nebula, but they are very, very faint. There was one I was able to get on the second night, and you could just tease it out. I think it was the southeastern curve on the bottom of it. You could just tease that out a bit, but it was very hard to continue that arc around with my aperture size. But it's a really nice target to track down, and that central torus is really bright. You'll pick it up quite easily, and it's really interesting to try to follow out that chain, and it really is reminiscent of trying to follow that outer gas layer around Messier 27 or the Dumbbell Nebula in Vulpecula. So for my observing sessions of Messier 76, I was using my 300mm or 12-inch Dobsonian, which is an f5 with a focal length of 1500mm. I was using my 3 main eyepieces that I tend to use, and that's a 24mm Explore Scientific, giving it a really nice field of view with that bright yellow-orange field star nearby, and the kind of open star field, and it really stands out against the background with the 24mm. But then I had to put a little bit of magnification on it with my 16mm eyepiece, and you could just see kind of a little bit more detail. You could see that darkish lane, the one that Herschel would have seen, where he split the 2 lobes into separate nebulae. You can see that with the 16 at about 100 magnification, and it holds up really well at the 100. It wasn't really until I moved to my 7mm that it just got a little faint, a little harder to get that detail out of. I tend to fall back to the 16mm at 100. For most observations I find it's really nice from my sight because I have a nice dark sight, so the 16mm works well. But with the 7 at about 200 magnification, it holds up kind of well. I was able to tease out the tiniest bit of the edge of that kind of gas that's pushed out from I think it's the northern lobe I was looking at, I think now, when it was inverted. But it showed up again when I went to the 7. I could see a hint, and then when I worked my way back out I was able to see it a bit better. So that is an advantage of using the eyepiece at that length. And that field star that's beside it sits at a distance of 260 parsecs, so it's about 850 light years. So you can kind of think of that as being maybe a quarter the distance towards Messier 76 when you're observing it. This is a really interesting little nebula to observe because you can see that dark lane just kind of sitting across the centre in your eyepiece with those brighter ends on it. So this was my first time observing Messier 76. It had been knocking around on a lot of observing charts, but I just hadn't got around to focusing on it. It was probably because of the size. It was quite small, and I was thinking with the size of my sensor, if it's at magnitude 10, that it might show up quite well. But with the RGB filters, I was able to get quite a nice image of it. And through my 12-inch, I was quite surprised at how bright the center of this looked. That central torus, that kind of rectangular shape, shows up really well in my 12-inch telescope. And it's an object that I think I'll return to. I'll try to get a couple of more observing sessions in the start before the summer, and then again afterwards when it works its way back up around past the northern horizon, because it's a really interesting little object, and I think I might be able to tease out a little bit more detail around the edge of it with a few more nights observing. So do let me know if you get out and observe Messier 76 over the next while, or any other objects, in the comments below. And until next time, clear skies!